Welcome to Session 20, Percent, Rate, Mixture, and Proportion. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to represent repeated percent changes with multiplicative factors, to build rate equations with consistent units, and to construct weighted mixture equations from pure amounts. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Distance, rate, and time relationships require compatible units. The triangle is a retrieval aid, not a substitute for modeling. Label each segment or mixture source separately, then combine quantities representing the same conserved total. The key distinction is this. Represent repeated percent changes with multiplicative factors. Then, connect it to the second goal. Build rate equations with consistent units. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Create a quantity table with labels and units. Identify the object being changed and the requested result. Step 2. Translate percent as a decimal multiplier and rate as quantity per time. Use a separate line so signs, units, and restrictions stay visible. Step 3. Write the conservation or equality relationship. Work efficiently without skipping an operation. Step 4. Test whether the result is positive, feasible, and correctly weighted. Whenever possible, verify with evidence independent of the original working. Signal 1 is successive percent changes. Respond by remembering, multiply change factors rather than adding percentages. Name the response before calculating. Signal 2 is catch minus up motion. In that case, set travel distances equal at catch time. The form tells you which tool fits. Signal 3 is mixture. Remember, equate total pure amount before and after. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. How many liters of 20% solution should be mixed with 50% solution to make 8 liters of 35% solution? Restate the target and identify the most important part of the routine. First move is, let X be liters of 20% solution. 8 minus X are 50%. This changes the form without changing the meaning. Next, write 0.20x plus 0.50, 8 minus X, equals 0.358. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Simplify. 0.20x plus 4 minus 0.50x equals 2.8, so minus 0.30x equals minus 1.2. State what the transformed line tells you. Complete the argument. Thus, x equals 4. The remaining 4 liters are 50% solution. This is part of the solution, not decoration. The final answer is 4 liters of each solution. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What multiplier represents a 12% increase? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Add 0.12 to the original whole 1. Use it to repair your setup rather than guess. An accepted answer is 1.12. Explain why it works and name the first step that would expose a common error. The central message is, represent repeated percent changes with multiplicative factors. Combine it with the discipline to build rate equations with consistent units. Finish by remembering to construct weighted mixture equations from pure amounts. This turns a calculated result into a justified answer. Reflection. Why is an unweighted average of 2 concentrations usually invalid? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 6 minutes, including a labeled quantity table. Keep the work readable, check it independently, and carry the routine forward.